we want to evaluate the given trig expression. We have the sine of 2 times arc cosine of -1/3. What's a little tricky about this one is we have this coefficient of 2 in the inner function. So let's start by focusing on the arc cosine of -1/3. Arc cosine of -1/3 is going to return an angle theta such that the cosine of theta is equal to -1/3, and because we have the arc cosine function, the output or range of this function is an angle theta on the closed interval from 0 to 180 degrees. So if we want to model this angle on the coordinate plane, since the cosine function value is negative, we know the angle must terminate in the second quadrant rather than the first quadrant. So our angle is going to terminate in this quadrant here. So we'll go ahead and sketch an angle where the initial side is here and the terminal side is, let's just say, here. So this is our angle theta, and if we sketch our reference triangle, this would be our reference angle, we'll call it theta prime. So using this reference triangle, because we know the cosine of the angle is equal to -1/3, we could label the adjacent side -1 and the hypotenuse +3. Now that we've modeled angle theta, let's go back to our expression. We can now rewrite this as sine of 2 times theta, or 2 theta. So this expression actually requires a double angle identity for sine 2 theta, which I provided here below just in case we need the review. So our given expression is going to be equal to sine 2 theta, which is equal to 2 times sine theta times cosine theta. So if we can find sine theta and cosine theta, then we can evaluate this expression. Well, going back over to our triangle, we have enough information for cosine theta, but we need to find the length of this missing leg here of this right triangle to determine the sine of angle theta. So if we label this y, we can now use the Pythagorean theorem to find the value of y. Y squared plus -1 squared must equal 3 squared. So we have y squared plus, this would be 1 equals 9. Subtract 1 on both sides. So we have y squared equals 8. Because we're in the second quadrant, we know y has to be positive. So now we'll take the square root of both sides of the equation, and we'll only consider the principal square root. So we have y equals the square root of 8. Remember, 8 is equal to 4 times 2. The square root of 4 is 2. So y is actually equal to 2 square root 2. And now we should have all the information we need in order to evaluate this expression. We'll have 2 times sine theta is going to be the ratio of the length of the opposite side of the hypotenuse. So that would be 2 square root 2 over 3 times cosine theta was actually given. That's going to be -1/3. Let's go ahead and put this 2 over 1, and now we'll go ahead and multiply. So we'll have -4 square root 2 all over 9, which means the sine of 2 times arc cosine of -1/3 is equal to -4 square root 2 all over 9. Okay, I hope this explanation helps.